that could be, let's say, fingerprints or the bullet or even the handwriting, the DNA. Actually, with the use of the individual characteristics, so if it is being matched, then there is no denying. Actually, you can know about the origin, so somehow 100%. But the case will not be that quite straightforward or too ideal. So sometimes we need to make use of the class characteristics in order to achieve the comparison purpose. So those kind of class characteristics will only pinpoint to a group of population. So that will not be an individual, will not be 100%. But if now you have quite a number of class characteristics together, so if all the class characteristics are being matched, actually that will be 100% to the origin at last. Because you can be imagine that in the world, there will be no then other kinds of object that will be matching exactly somehow the same with another. So with the use of the class characteristic, although one class characteristic will be pinpointed to a group, but several class characteristics together, so all the group will be somehow converge to an individual. Somehow we can do like this way. But before we can really conduct the analysis for the identification, at the same time for the comparison in the crime lab, actually we need to go for the crime scene. So we have the crime scene at the very early beginning. So mainly because with the crime scene, we try to obtain the sample. So this kind of sample, actually we say to be they are the physical evidence so that we recover at the crime scene. So those kind of physical evidence, actually we have three different types. It could be some objects, or it could be some body materials, or it could be some impression. But no matter what, so when we arrive at the crime scene, we try to obtain some critical physical evidence, take it back for the crime lab to conduct the analysis in order to provide with the accurate and objective information. So that is really important, that how we can process with the crime scene. So last time we have been showing you 7 from the mental practice, so how we can process the crime scene correctly. So the first step that is related to the isolation. So we try to exclude out all the unauthorized person, because they are the potential destroyer for the physical evidence. So secondly, we try to record the crime scene in its untouched status, using the photo and also using some drawing. So after we obtain the record, then we try to take some notes, so as some detailed written description, so how we process the crime scene in order to making sure that we have a proof, so that we are doing something correct. So the next thing that is we try to conduct a search, the search for the physical evidence. So the search should be systematic, and also that should be quite in details. So without missing any of the area at the crime scene, because if you miss some of the region, missing some of the area, actually some of the physical evidence may not be recovered, then actually that would be a disaster. So after you conduct a search, so probably you could be able to find out, so what kinds of physical evidence are there. Then you try to collect it using the proper container. So last time we have been mentioned to you, there are several different kinds of container that we can use. For example, like for some powder, we can make use of the drugless flow. For the volatile substance, we can make use of the airtight container. Or now we have some small object, then we can put it inside the school cap vial. So with the blood-stained object, then we can put it under the paper bag. So if now some object is quite large, then we can simply put it into the plastic bag. So actually we need to collect it somehow in a proper way. So one evidence in one container to avoid any contamination or damage. So after you collect the evidence, then you have to establish the chain of custody. So the chain of custody will tell you the possession of the physical evidence. So that means, okay, within all the time, okay, so who own the evidence. So that will be quite in a trouble if the evidence has been missed, okay, for any 1 second. So that missing 1 second will be quite doubtful that maybe the evidence has been replaced by another, or some people has been doing something wrong, okay, with the evidence. So we have to make sure that at any time, okay, we know, okay, who own the possession of the evidence. So at last, we try to prepare the evidence submission form. Then the evidence will be submitted to the lab, okay, so to conduct the analysis to obtain the accurate and objective information with the purpose for the identification and the comparison. So last time, at last, okay, I have been mentioned to you that there are some procedure that is really critical, okay, because if you don't follow those kinds of procedure, your evidence will be disqualified. So if any of the evidence was disqualified, actually you will be missing out those kind of linkage. The first one would be the record, okay? So we have to make sure that your evidence has been photo, and also the drawing will show where they are, actually to be able to know the evidence is really recovered at the crime scene. The note-taking exercise is also important, okay, because those kind of written description showing you how to possess the crime scene. So we have to make sure everything that is correct. And then in terms of the collection process, so using proper container without any contamination, without any damaging, and at the same time, you have to apply the warrants, okay, in order to take out the evidence. And then the chain of custody, actually, I have been mentioned to you that if we have some time, okay, even 1 second, so that is quite doubtful already. So because of the principle, okay, for the benefit of doubt in Hong Kong, or somehow in most of the country in the world. So actually, if now, okay, some of the evidence has been disqualified, so actually the case may not be convicted. So after all the steps, okay, has been go through, okay, so now we have the accurate and objective information. So at last, we try to pay with the crime scene reconstruction. So that will be the crime scene reconstruction, okay, so somehow be in the last step. So we have to apply our logical thinking and then try to propose in reasonable sequence of the events. Okay, so what was happened? So what was likely happen at the crime scene? Okay, so it may not be exactly 100%, okay, exactly the same, okay, because we don't have any time machine, okay, in order to fly back, in order to see what was happened. But right now, based on the information that we obtain, and together with the our logical thinking, okay, then we try to be retrieve, okay, the whole story and then present in the court to see how the case was convicted or not. So that is what we have been mentioned on last Tuesday. So any questions or problem at this moment before we start to talk about the new lecture material on the abused drug identification? Okay, so thanks for the reply. Okay, then I assume no question at this moment. But actually, so my writing. So any reply from the student? Okay, so can you see my writing clearly? Okay, so is it good enough, okay, for you to know what I'm writing? Okay, so thanks a lot. Okay, so then we move, okay, to the next lecture material. So that will be the abused drug identification. Okay, so let me flip, okay, the A4 size paper. So now, okay, we move, okay, to the new topic. So although, okay, that has been said to be abused drug identification, But actually, we can simply say, okay, so that is related to the drug analysis. So right now, you could be imagine that we are having some drug, okay, so we cover at the crime scene. So we want to know, okay, so what it is. And then at the same time, we want to know, okay, so the respective amount and also knowing about the respective origin. So that is the drug analysis. So for this lecture material, we will start with the definition of drug, and then I will further talk about how the drug is being classified, and then I will talk about how we can do the drug sampling. Then we will start to go through the whole scheme for the drug analysis. Okay, so let's start with the drug definition. So for the drug, that is some substance, okay, being used to produce some psycho or physiological effect in human. So that means that, okay, with taking the drug, okay, so the human, some of the function will be being altered, okay. So it could be some physical change, or it could be some mentally change. So what has been changed, okay, maybe you can be saying that you take the drug, okay, because you are now having the running nose, okay. Then you take the drug, then the drug helps you to stop the running nose. Or now you have headache, okay, then you take in the drug, then the headache stop, okay. So physically, okay, so now you feel better. So without running nose, without the headache. So at this, and the other times, okay, maybe now you are feeling sad, okay, so you are unhappy. So now you are taking in some drug, okay, then to make you feel happy, okay. So actually there will be some mental change, okay. So if you hear from me like this way, okay, actually the drug, okay, so by default, that is something good, okay. So the drug itself, okay, if you are taking the drug under the prescription from the medical doctor, so actually the drug will bring you some positive effect. So those kind of positive effect will be including the disease treatment, cure the disease, prevention of the disease, or even the disease diagnostic. Okay, so most importantly, they are quite positive. Okay, enhancement of your physical and mental well-being, because they treat you physically and treat you mentally. And then now, okay, with the change of your function, then actually everything just feel good. But sometimes people will have some misunderstanding, okay? So taking the drug now having the positive effects, but they are now, okay, abuse it, okay? Because they feel happy, they feel good, then they try to self-administrate the drug, okay, by themselves, okay, for some non-medical reason. So because they have some past experience that they take in the drug and they feel good, then they will be saying that, so I keep on taking the drug, then I will feel good forever. So now, okay, the drug, okay, originally with the positive effect, but now that has been abused, okay? So without any medical doctor advice, without any prescription, then you just take in, okay, so for non-medical reason. So with the abusion, actually, finally, that will lead you with the negative effect. So actually, that would be a problem later on, okay, if you abuse, okay, a drug. So no matter that is the health issue, okay, or that will be a social issue if we have a lot of people abusing the drug, okay. So actually, that will be a problem, okay, if some of the drug that is being abused, okay. But for our analysis or for our goal, it is not really to say, okay, whether now, okay, a person has been abusing a drug or not, but actually that is something in between, okay, the drug itself and the abused drug. Because the drug, okay, could be classified to be the legal drug, okay, something that is legal, and some of the drug that is illegal. For the illegal drug, we say that that is the illicit drug. For those kinds of illicit drug, okay, so why, okay, they are illegal, or why the government set up some regulation to monitor it? Mainly that is because those kinds of illicit drugs are paired with the habit formating property. So that will be habit forming. Okay. So with the habit forming property, so when some of the people taking in those kind of illegal drug, actually they will be having the dependency. Okay, so people will depend, okay, on the drug and try to addict it, and then they will be abuse the one. So if you see the linkage, okay, in this way, so the drug itself, so why it is being abused, most importantly, the one that has been abused would be the illegal one. Okay, so that is the reason why what we try to pay attention, that is the illegal drug, because they are illegal and they could be easily addicted, and then people will take it, okay, for non-medical reason, and then that will be quite dangerous. But I didn't mention to you that, or I didn't say to be the legal one, actually you still can abuse it, but actually they are without any dependency, you can stop, okay, so by yourself. But actually you still can abuse, okay, those kind of legal drugs. But right here, what should be assumed, okay, so in the drug analysis inside the crime lab, so that will be the place, okay, right here. We try to know, okay, if we have the drug sample being found, okay, in the crime scene, whether that is a legal one or whether that is a illegal one. So if this is legal, then actually there may not be that a problem, okay. But if you abuse, okay, a legal drug, okay, maybe you will send it into the 戒毒所, okay, so some center to help you to get rid of the drug addiction. But if now, okay, you are having the illegal drug, okay, with the small amount, maybe you will be charged, okay, to be saying that you are 藏毒. So now you are owning the drug, okay, then you will be sent to the prison. Or if you're owning a lot of illegal drug, so you may be charged, okay, by selling the drug. So that will be 販毒. So therefore, the penalty will be even higher. So that is somehow why, okay, we have to conduct the drug analysis. So basically, we try to differentiate out whether that is the legal one or the illegal one, and then later on we try to see, okay, how much are there, and then we will be know, okay, whether that is 藏毒 or 販毒. So in terms of the drug, okay, most importantly, or one of the classification, we try to classify the drug according to the respective effect. So normally there are 4 types of drug, okay, if we are saying with the effect. So the first type, that is the narcotic, second one, that is the depressant, the third one, that is the stimulants, and then the fourth one will be the hallucinogens. So for the first type, by the name, okay, you will be know that is the painkiller. The narcotic drug, okay, the narcotic drug, okay, so this one, narcotic drugs. So they are the painkiller. So now, okay, if you take in the narcotic drug, okay, so actually you will feel without any pain, okay. So without any pain, okay, actually you will be quite comfortable, and then you will be able to fall into sleep, okay, easily. So for the narcotic drug, one of the quite common kind, that is the opium, arpin. Okay, so those kind of opium, they could be extracted from the popper. Okay, so that is the unsokfa. So the active ingredient in the opium, that could be the morphine, so that is the mafe, or it could be the codeine. Okay, so that will be naturally occurring in the opium. So with the morphine, actually we can do a very simple chemical modification, and then that will become the heroin. So that is the 海洛因. So actually we will regard the morphine, heroin, codeine, okay, so these 3 as the opium derivative. So they are the arpin, okay, so that is the narcotic drug, okay, one of the most common kind. And then for the other kinds of narcotic drug that you could be found, okay, commonly, that is the ketamine. So ketamine in Chinese, that is the K仔. Okay, so actually that is one kind of anesthetic. Okay, so being used, okay, for some surgery. But actually people will try to abuse it in order to fulfill, okay, the painkiller. So for the second one, that is the depressant. So actually by the name you know, okay, if you take in the depressant, actually that will slow you down with the central nerve system. So if you are being slowed down, actually you will fall into sleep easily, okay? Because now when you slow down, then you are feeling quite relaxed, and then actually it will be quite easy for you to fall into sleep. So the most common kinds of depressant that you could define, that is the barbiturates. So for the barbiturates, that is the 安眠藥. So by the name, you know, okay, that is the medicine, okay, to help you to get into sleep, okay. For the other one that is quite dangerous, so let's say that is the GHB. So in Chinese, that is the 迷奸水. So somehow when you take in the GHB, actually you will be slowed down a lot, and then actually you will just not only fall into sleep, actually you will be fall into a coma. Okay, so actually that will be just try to slow you down. Okay, for the depressant. So in an opposite of the depressant, then we have the stimulant. So stimulant, that is the drug, okay, to speed you up. Okay, so somehow will be activating your central nerve system. Then you will be quite awake, quite energetic, and you will forget tired, you will forget fatigue, you will forget hunger. Actually, you will be keep activating. So after you have been activated for some time, okay, actually you will be over exhausted. So finally, you will still fall into sleep, okay, but right before you fall into sleep, okay, before over exhaust, actually you have been somehow quite activated. So for example, okay, cocaine, methamphetamines or the amphetamines, they are the quite common kinds of stimulant that you could be fine. So cocaine actually 海洛因, okay, so actually you know可卡因, okay, so 可卡因, okay, so cocaine, so actually you know what it is. And then for the methamphetamines in Chinese, that is the 甲基安非他命. But actually we have a layman term for it, so that is the ice, so 冰毒, so that is the methamphetamines. So for the amphetamines, that is the amphetamine. So I guess, okay, you have been heard, okay, from this kind of name, okay, so previously. For the last one, that is the hallucinogens. So for the hallucinogens, actually they will give you some false prescription. So what it means is, after you take in those kinds of hallucinogens, you will be seeing something that we cannot see. You will be hearing something that we cannot hear. You could be smelling something that we cannot smell. So actually, your perception, okay, actually they are quite wrong. Okay, so actually you can be sensing something the normal human being cannot sense. Okay, so for the typical one, that could be the marijuana, okay, or in another name that is the cannabis. Okay, so in Chinese that is the 大麻. So for the other, we still could be finding the ecstasy. Okay, so ecstasy would be the last one. Okay, so ecstasy. So ecstasy in Chinese, that is the 凤頭丸. Okay, so if you take in the ecstasy 鳳頭丸, actually you will be shaking your head up and down. Okay, somehow continuously. So right now, you may ask, okay, why? Okay, before we talk about the food analysis, we have to know about a little bit on the effect of drug. Because for those kinds of effect, okay, we can be able to make use of the effect as some background information to help us, okay, with the food and the drug analysis. Because for the drug, okay, it will be quite a lot. Okay, so we have a wide range of drug. So if now you could be seeing some white powder, seeing some blue color tablet, so actually you don't know what it is, okay? And if you don't know what it is and you start to deal with your drug analysis, actually you won't be able to set up an appropriate protocol, okay? So if you cannot be able to set up an appropriate protocol, so actually we cannot be guaranteed that the result that you obtain, okay, will be somehow good enough. So that's why, okay, when we arrive at the crime scene, apart from sampling the drug, so we try to see, okay, those kinds of people, okay, so their respective behavior or what kinds of effect are there, okay, in order to help us to narrow down the number of possibility. For example, like if now you are seeing the people after taking the unknown drug, okay, they are quite activating. then you know, okay, those kind of unknown drug could be one kind of stimulant. Okay, so now, okay, with different kinds of drug, then you narrow down to one class, okay, of it. Or maybe now, when you arrive at the crime scene, then you are seeing those kind of people who have been taking the drug. You see they have been asleep, okay, so somehow for a long time, okay, they cannot wake up, okay, they fall into sleep easily. Then you may guess, okay, so those kind of unknown drug, they could be a certain kinds of depressant. Or now, okay, the people are saying they are seeing something supernatural, okay, so something supernatural. So you will know, okay, they will be a certain kind of hallucinogen. So therefore, this kind of effect, okay, they are quite a good background information to us, okay, to narrow down the number of possibility. So that is the reason why before we really talk about the drug analysis, so I have to talk about a little bit on the respective effects. So actually, apart from classifying the drug according to the effect, we still can classify the drug according to the origin. So let's say the natural one or the synthetic one, or even classified by the places that we take in the drug, but actually they will be out of the scope, okay, of the courses, okay, because what we try to focus, that is the drug analysis. So after knowing what you mean by drug, and also from the effect, that would be a quite good enough background information to us. So right now, we try to focus a little bit on the drug sampling. So doing a drug sampling, that is something quite straightforward. So because they most of the drug, okay, they are, let's say, powder or tablets, okay, so some small pieces. So if we would like to take up those kinds of powder or those kinds of tablets, so actually we have to make use of the drugness flow. Okay, so last time I have been told you that if now we have the powder or tablets, okay, because they are quite small in size, if you just put into the screw cap valve, actually there will be a leakage. Okay, so somehow you're losing your sample. So somehow to avoid the loss of the sample, so we have to make use of the drugness flow, okay, in order to sample those kind of powder and tablets, or even the somehow of the capsule, okay, so some small pieces. So we try to put it inside the drugness flow. But it doesn't mean that all the drug, they are suitable to put it inside the drugness flow, because some of the drug, okay, they are volatile. Okay, so some of the drug, they are volatile in nature. So some of the drug, they are not being taken, okay, orally. So somehow some of the drug you have to breathe in, okay. So for those kinds of volatile drug, okay, you have to put it inside the airtight container. So because if they are volatile, then they will be quite easy to be escaped as vapor. If you just put it inside the drugness flow or even the glass valve, actually you are losing your analyte. So that is the reason why for some kinds of volatile drug, you have to put it inside the airtight container. But last but not least, okay, most importantly, while you are doing the sampling, try to take a look, okay, so on the background information, okay. So those kinds of background information, they are the effect or the behavior, okay, so coming from those kinds of people who have been taking the drug, okay. So that will be somehow we do it at the same time, okay. So you sample the drug, at the same time you try to collect, okay, the background information. So now, okay, you can be assuming that we have the sample ready. So before, okay, we make use of the drug analysis, so we have to get to know a little bit, okay, so what kinds of difficulty will be there. So apart from powder, tablets, or capsule, so actually the drug could be of different kinds of form. It could be cigarette, it could be liquid, or let's say the inhalants, okay, so those kind of volatile organic compound. So therefore, it may not be that straightforward, but under powder, under tablets, under capsule, so there will be certain kind of solid sample. Then you may just try to dissolve, okay, the whole powder, whole tablet, or whole capsule, okay, so to prepare your sample solution. But now if it is a liquid, okay, maybe you have to pay with the dilution. If that is a cigarette, okay, maybe that is a tobacco or that is the marijuana cigarettes, then they will be having some biological matrix, okay, then you have to do some rigorous extraction, okay. So that will be a very important step, okay. So when we are dealing with different kinds of sample type, so what kinds of sample preparation or sample pre-treatment that we need. So besides that, inside the drug, that is not only contained, okay, with the active ingredient. So what I say is, inside the drug, it is not the active ingredient only. They will also contain some kinds of dilutants. So let's say it will contain some sugar, some starch, or even some quinine, or even some glass powder are there, okay? So those kind of sugar, starch, quinine, or glass powder may exceed, okay, with the matrix effect. So with the matrix effect, somehow it will hurt, okay, your analysis. So with the matrix effect, maybe underestimation, or now the matrix overlapping with your signal. So actually, during the sample pre-treatment, you may, okay, need some extraction instead of the complete dissolution of the sample. So the other thing that you have to pay attention is there's no middle ground in the drug analysis. So we have to really confirm what it is. To confirm, it is not only confirmed once only. So in the whole analysis, we have to confirm it by at least 2 times, okay? So what I say is there would be a double confirmation. So we have to apply the confirmatory test somehow at least for 2 times. Maybe the first time we apply GC, second time we apply the mass spec. So at least, okay, we have 2 information obtained and then to confirm what kinds of drug are there. So owing to a situation that for some drug sample, okay, for some physical evidence of the drug sample, the sample size may not be that large. Maybe you are having just 1 gram, okay, of powder, or even a few milligram of the powder, okay. So actually, with those kinds of small sample size, okay, if you have to go through a double confirmation, and there may be a problem. Because you are doing an analysis, the sample will be consumed. If all the sample has been consumed before you doubly confirm what it is, actually you cannot draw any conclusion at last. So that is the reason why during the analysis, we have to think a way that how we can preserve the sample, how we can retain, okay, so most of the sample, and then to be sufficient, to be enough, okay, to go through the whole drug analysis. Okay, so here we get into the main content. So how the drug analysis is performed. So for the drug analysis, although right here I list out 8 different steps, but actually we can just try to group it into somehow 5 only. So for the analysis, okay, so we have 5 steps there. The first step, okay, that is the visual examination, okay. So we try to do some visual examination on the drug, okay, so for the grouping, and then on the plastic bag, so that is the container for the drug itself, in order to check back the origin, so that is the comparison purpose. And then after we finish the visual examination, then we try to apply the screening test in order to do some screening, in order to further narrow down what kinds of drugs are there. So now approximately you know what it is, then you have to do some sample pre-treatment, okay? So in order to prepare the sample solution, so for the instrumental analysis. Because for those kinds of confirmatory tests, okay, in order to confirm the identity of a drug, okay, so they are the instrumental analysis. So you can be imagined that for those kinds of instrumental analysis, the sample that we need, okay, should be a liquid. Okay, so that is the reason why for the sample pre-treatment, we have to turn, okay, those kind of solid powder, solid tablets, okay, into a liquid. So at last, we try to conduct a retest, okay? So somehow we try to repeat, okay, the confirmatory test by another kind of instrument. So try to double confirm, okay, the respective identity. So that is the 5 step, okay, so overall 5 steps, okay, so inside the drug analysis. So now, okay, let's start, okay, to talk about the visual examination. So don't worry, okay, so I will go through each of the steps somehow in detail so that you will be able to know, okay, so what kinds of stuff, okay, are happening inside. So the first step that is related to the visual examination. So for the first kind of tasks, okay, we have to make use of our naked eyes, okay, so just making use of our eyes in order to look at the drug, in order to group them as an individual drug. So for some cases, that is quite straightforward. Okay, maybe you are now seeing white color powder, and then all the sample are white color powder, and then we assume that they are one kind of drug. Or maybe now, okay, you are seeing some blue color tablets. So all of them, they are blue color tablets. They are the same, and then we could be assumed that they are one kind of drug. But for some situation, you may be seeing the drug is somehow a mix of a different kinds of drug. Maybe now you will be seeing some circle, okay, so for the shape. Maybe you are seeing some of them, they are triangle. Maybe you are seeing some of them, they are square. So actually that is the unknown sample that you take, okay, from the crime scene. But right now, you cannot be say, okay, circle equal to triangle equal to square. Okay, we cannot assume, okay, the circle, triangle, and the square, they are the same kind of drug. Because by the appearance, okay, they are different. Then in order to avoid, okay, any problem, okay, so we try to group them individually. Okay, so we could be able to say, okay, the circle one, we group it, so that is the first group. The triangle will be another group, and then the square will be another. So with the same form, same color, or even the same texture, okay, so we will group, okay, as an individual group, okay. Within a group, then we assume they are an individual sample. So that is quite important. Because if you try to mix it, maybe you will have a wrong conclusion. Maybe the circle one that is morphine, and then the triangle one that is barbiturous, and then the square that is ecstasy. And if you group it individually, then you will be able to know, okay, circle that is something, triangle is another thing, square that is another. But if you now, okay, without grouping, you just try to mix them together, then you will be saying that, so for the drug, okay, it contains 3 ingredients. So actually, it will be a wrong conclusion. So that is the reason why at the very early beginning, so we have to conduct the visual examination. So trying to group the drug, okay, so individually. So maybe just giving you some one more example. Maybe let's say right here, one of the square that is blue color, and then the other that is white. So actually, we will also try to separate them into 2 groups. So just according to the color, according to the form, okay, so we try to group them individually. So apart from making use of our naked eyes, sometimes we have to make use of the low power microscope in order to look at the cross-sectional area of a drug. Because for some of the drug, they may have some coating, okay, on the surface. So you may be able to see that, so this is the one without coating. And then versus, let's say, this one, okay, so that is with the coating. So you will see some coating on the surface. Maybe they are of the same form, they are of the same color, but they are different, okay, because of with coating and without coating. But for the coating, that will be done, okay, by the low power microscope. But right at this point, okay, the first thing that you know, based on the visual examination, the first thing that we are checking with, that is the drug itself. So with the drug, we try to group them individually. So that is the first task, okay, that we have to do. So from the drug, we do a grouping. So apart from checking with the drug, okay, so we try to check with the plastic bag that is containing the drug. Because then you could be imagine that different drug seller or different drug manufacturer actually, if they are selling the same kind of drug, the active ingredient will be more or less the same. So let's say if I'm selling some medicine, okay, to treat fever, okay, so actually everybody will just try to make use of the paracetamol, okay. So from different kinds of drug manufacturer, if they are selling these kinds of cold relief medicine, actually all of them contain paracetamol. Then we don't know, okay. So actually that is been shown by manufacturer A or shown by the manufacturer B, or even okay shown okay by any kinds of people. If we just okay look for the active ingredient of the drug, then you still could argue, okay, so how about we further check with the diluents? Actually, diluents will also be quite in general. So for most of the drug, okay, they will contain sugar, starch, quinine, or even the other, they are quite general substance. So actually, based on the drug itself, it is really hard for us, okay, to get back the origin to achieve the comparison purpose. So that is the reason why we further check with the plastic bag. So actually, that is the container of the drug. So from the plastic bag, that will be achieving the comparison purpose. Okay. So why is the case? So based on the plastic bag, actually we could be able to see some class characteristic. So let's say we could be able to see the size of the container. We will be able to see the appearance of the container. So actually that is one kind of class characteristic that we could be see. Maybe now, okay, manufacturer A, okay, showing the drug with a blue plastic bag. And then manufacturer B are selling with the similar kind of drug, okay, using a colorless plastic bag. So actually, based on the plastic bag, the color, then we could be able to tentatively know, okay, so which manufacturer selling the drug. But size and appearance, it is a certain kind of class characteristic. And as far as you know, okay, we need some more. That's why, okay, apart from comparing with the size appearance, so we may further check with the refractive index, okay, of the plastic bag, or even we check with the density of the plastic bag, or we can further check with the chemical composition of the plastic bag. So in order to know, okay, so is it really the one, okay, that is coming from that manufacturer, or is it really the one, okay, coming from that drug seller? So actually here you could be see 1, 2, 3, 4, 5. Okay, we have 5 class characteristics that will be used, okay, together. Apart from this kind of class characteristics, so actually when we look with the plastic bag, there is one, okay, unique things, that is the exclusion mark. For the exclusion mark, that is an individual characteristic for a plastic bag. Okay. So somehow, if you can be able to see, okay, with the low power microscope, then actually, if you could be able to review, okay, the exclusion mark, basically, no need to check with the class characteristic. Then right here, you may ask, okay, so what do you mean by the exclusion mark? So actually, that will be coming from the plastic bag manufacturing process. So normally the plastic bag, okay, they are being made, okay, by rolling out the plastic sheets, okay. So at the very early beginning, a plastic sheet, okay, will be rolled out, okay, from the plastic bag machine. So those kind of plastic bag machine, okay, when they roll out the plastic sheet, actually they will left behind some extrusion mark, okay, so on the plastic bag. Okay, so something you cannot be see, okay, by our naked eyes, but you can do it by using the low power microscope. So once, okay, the plastic sheet, okay, has been rolled out, then people will try to cut it and then cut it and then cut it, okay, into different bags, okay. So we have the first one, second one, the third one, and the fourth one. So when you're cutting out the bags, okay, actually you will be seeing that those kind of extrusion marks, they are connected to each other, and then now you just try to cut them away. Okay, but if you can be able to find, okay, the two aside, okay, plastic bag, So you could be just like a puzzle, okay, that you could be able to connect at the extrusion mark. Actually, you could be able to link up the drug manufacturer or the drug seller, okay. So that is the individual characteristic that you can use, okay. But if you can be just making use of the naked eyes, then size and appearance, for the refractive index and the density, it will also be a quite easy task, okay, to finish, okay. But most importantly, right here, under the visual examination, so we have to look for the drug for the grouping. We have to look for the plastic bag for the comparison purpose in order to check back for the origin. Okay, so right here, maybe I first give you a 10 minutes break, okay? So before we move into the screening test. Okay, so let's resume our lecture after the break. Okay, so can you still hear from me? Okay, so thanks for your reply. Okay, so for the past 1 hour, so we have been studying the new lecture material on the drug analysis. So we first give you a definition for the drug and how the drug is being abused. And then in view of the drug analysis, so what kinds of main objective that we are focusing? Okay, so actually that is the legal versus the illegal drug. Then we talk about a little bit on the sampling. So what kinds of container that we have to use. And during the sampling, we have to obtain some background information in order to help us to narrow down the number of possibility. And then we start to talk about the analysis, starting with the visual examination. So for the visual examination, we have to do the visual examination of the drug sample in order to do the grouping. And for each of the group, okay, then we assume that it's an individual kind of drug. And then we do the visual examination of the plastic bag in order to check out the origin. So that is the comparison purpose. So right now, we move forward, okay, so to the second step, okay, so that is the screening test. So for the screening test, that is a test, okay, try to further narrow down the number of possibility. Because from the background information that is still not good enough, maybe we can just narrow down to a class of the drug. But right now, we try to narrow down to some kinds of drug only. Okay, because for the sample pre-treatment and for the confirmatory test, we really have to know, okay, what tentatively it is, okay, before we can really set up an appropriate protocol. So for the screening test, okay, the first kinds of screening test that we will talk about that is related to the color test. Okay, so for the color test, okay, actually by the name, okay, that is a test that will result with some color. Okay, so with the color, then actually we could be able to differentiate out whether that is positive or negative. So from the positive and the negative result, tentatively we could be able to know. Okay, so it may be okay, so that kind of drug, or it may be okay, not that kind of drug. So by the color test, that is the one common kind of screening test. So actually the principle behind that will be quite straightforward. So now we have some drug sample. So we try to add in some specific reagents. Okay, so the reagents are specific. And then after they are being related, so that color will be observed. So those kinds of color, okay, will be saying to you that is a positive or negative result. So positive result, and that will be quite good, okay? We can know what kinds of things it is. However, if it is negative, actually that will still be good. Because for the negative result, that is a good indicator for an absence of a particular substance. So what it means is, for example, like we have a color test to test for the marijuana. So if it is negative, then we know, okay, the drug that we have, okay, the unknown one that is not marijuana, okay. So no matter positive or negative, they are still a good result. But bear in mind that right now we are now having the screening process. So none of the color test is confirmative, okay. The identification will not be conclusive. It mainly because, okay, for the reagent that we are using right here, they are specific only. Okay, they will be reacted to a group of drug instead of they will be reacted uniquely, okay, to a single kind of drug. So that, okay, after we have the color positive, okay, the drug that we have, okay, will not be a single one. Okay, it will be a group, okay, there. At the same time, if we have the other kinds of matrix, okay, the other kinds of substance, they are not drugs, okay, but they share similar kinds of structure. Actually, they would also be reacted. So therefore, you may have certain kinds of false positive result. Okay, so in that sense, the result that we have that is tentative only, okay, then that will be quite good enough, okay, to deal with the screening purpose. At least we know, okay, it may be, okay, so those kinds of substance. So for the color test that will be done on a spot page or in the test tube, therefore, in another name, okay, for the color test, we say that that is a spot test, okay, and the test that is destructive in nature. And basically, we don't try to apply so many color tests. So we just try to fulfill, okay, the screening purpose only. So don't try to use, okay, all kinds of color tests in order to know, okay, what it is, okay. If now you are using up the sample and then you don't have sufficient sample for the further analysis, then you cannot achieve the double confirmation. And at last, okay, you are falling into a problem. So for the color test, actually, before I give you all the details, so at the very early beginning, what I want you to know is we have one preliminary color test. So that is the one, okay, that you have to do at the very early beginning. And we have 5 primary color tests, okay? And then we have quite a lot of secondary color tests. So I will show you the test, okay, somehow one by one, okay, with some example, and then you will be know, okay, so what exactly it is. To start with, okay, so we will start, okay, with the Marcus reagent. So Marcus reagent, that is one kind of primary color test, okay. So Marcus reagent, okay, so one kind of primary color test. So simply, I will just put down a big M, okay, so Marcus reagent. So Marcus reagent is used to test the presence of the opium derivative or the amphetamines. So what it means is that is a color test to test for morphine, heroin, and also the codeine. Okay, so these 3, okay, are the opium derivative coming from the popper. Okay, and for the amphetamines, that could be the original amphetamines, or that could be the methylamphetamines, that is the ice, or even that could be the ecstasy. So ecstasy will also be a group of the amphetamines. So right here, what you can see is the Marcus reagent, that is a quite simple reagent. That is a 2% from formaldehyde in sulfuric acid. So now you have the drug sample, then you add in the 2% formaldehyde in sulfuric acid directly into the drug sample. So if it turns, okay, to purple color, okay, so if it turns to purple, then right here you will know, okay, so that is the opium derivative. Purple color will be corresponded to the opium derivative. If the Marcus reagent turn into a brown, okay, so brown in color, then that could be amphetamines or the methylamphetamines. If the Marcus reagent turn into black, okay, then that would be the ecstasy. So depending on the color that you have, okay, then you will be able to know, okay, so what kinds of unknown it could be. Purple, that could be heroin, morphine, or codeine. If it is brown, then that will be amphetamines or ice. If it is black, okay, then that will be the ecstasy. So why, okay, those kinds of Marcus reagent will be able to help us to generate, to reproduce with the color. So mainly because when you look at the screen, okay, at the left-hand side, so for each of the drug, okay, that we are tracking, so no matter that is the opium derivative or that is the amphetamines, actually they will have the benzene ring, okay, by itself, okay. So there will be one benzene ring, okay, from each of the drug, okay. So you could be imagine we have one benzene, okay, so a aromatic ring, okay, so from, let's say, from the morphine. And then we have another aromatic ring, okay, so from another morphine, okay. But at this moment, actually, that is colorless. So once, okay, you have the 2% formaldehyde. So the 2% formaldehyde will be used as a bridge in order to connect, okay, the drug compound together. So with the conjugated double bond right here, then you will be able to see, okay, the color. But all in all, okay, what you try to know is the color that we have, and based on the color, what kind of drug it could be. So purple, that will be the opium derivative. If it is brown color, then that will be the amphetamines or the ice. If it is black, okay, then that will be the ecstasy. So that is the first kind of primary test, okay, that we need. So the other kinds of primary color tests, so that is the Daly-Copenhagen reagent. So we can simply say that that is the DK reagent. So Daly-Copenhagen reagent. So this is used, okay, to test for the presence of the barbiturates. So actually, barbiturates commercially we have more than 20. They are coming from the barbiturate acid. So barbiturate acid by itself, okay, it is not a depressant, but we can modify the respective side group, okay, then they will become barbiturates. So with the barbiturates, then commercially we have more than 20, okay, but no matter how, okay, once they are barbiturates, then they will be able to turn the Daly-Copenhagen reagent into purple color. Okay, so right here you could be see, okay, if it is positive, then the Daly-Copenhagen reagent will turn into purple, okay, if it is the barbiturates. No matter which kind of barbiturates, okay, so it will turn into purple. So for the Daly-Copenhagen reagent, actually it is a little bit complicated, okay, because it will contain two, okay, solution inside. The first solution, that is the 1% cobalt acetate in methanol. The second solution will be the 5% isopropylamine in methanol. So you have to add the two solution step by step into the unknown drug sample. You cannot, okay, add the two solutions together. You have to first, okay, add in the cobalt acetate, and then, okay, you add in the isopropylamine. Okay, and then if you could be able to see the purple color, then that will be the barbiturates. So right here, for the color formatting principle, so right now you are seeing cobalt acetate. So actually we are making use of the cobalt center. So the cobalt itself, okay, will be acting as a methyl center. Then the barbiturates, okay, so will be acting as a ligand. And then the isopropylamine will be acting as another two ligand. Then the complex, okay, will be of purple. Right here, you will be getting an impression, okay, actually why you have to add in the two solutions separately. Because if you try to add in the cobalt and the isopropylamine together, the four ligand, okay, connected to cobalt will be all of the isopropylamine. So none of the barbiturates will be able to bind to the cobalt. Actually, that will be still colorless. Then that will be a false negative result. So that is the reason why we have to add in, okay, the cobalt acetate in the first time, and then add in the isopropylamine in the second time. Okay, if it turns into purple, then that will be the barbiturates. The third kind of primary color test, so that is the diquinose-Levene reagent. So it could be simply say to be the DL reagent, so diquinose-Levene reagent. So that will be used to the test for the presence of the marijuana, so that is the cannabis. So inside marijuana or inside the cannabis, the active ingredient that we are checking, that is the THC. So that is the tetrahydrocannabinol. Okay, so that is the THC. So most likely for the drug law, okay, actually they are regulating the THC, okay, but actually in the world, okay, you may know, okay, in the marijuana we have another kind of ingredient known as the CBD. Actually, it is not being monitored, okay, so only THC that is being monitored. So that is the reason why we are checking for this active ingredient. For the diquinose-Levene reagent, actually it contains three, okay, bottle of reagent. The first one, that is the 2% vanillin together with the 1% acetyl acetate in ethanol. The second reagent, that is the concentrated hydrochloric acid. And the third reagent, that is the chloroform. So by the previous Daly-Copenhagen reagent, actually you know, okay, so now we have three different reagents. We have to add to the unknown drug sample somehow one by one. So after we add in the first reagent, actually nothing changed, okay, you will still be able to see colorless. Once you are adding in with the concentrated hydrochloric acid, then it will change to purple. So purple color will be formed after you add in the second reagent. So at last, okay, you will try to add in the chloroform, okay. Finally, you will see in 2 layers. So that will be purple over purple if it is the THC. So you may be concentrated hydrochloric acid or the ethanol that will be forming the upper layer, and then chloroform layer will be the bottom one, okay, because chloroform, the density that is larger, okay. So right here, you have to follow the exact sequence of the color changing, okay, in order to tell that is a positive result. Colorless purple to purple over purple. So that is the color sequence, okay, for the positive result of the quinoline reagent. So right here for the color formating principle, actually that is the somehow a conjugated double bond mechanism. So from the THC, you will be able to see with the aromatic ring, and then from the vanillin, that is an other kinds of benzene ring there, aromatic ring there. Okay, so sorry. Okay, so okay, so you will be able to see. Okay, so from the vanillin, so you have an other kinds of aromatic ring. Then the 1% acetoacetate will be used as a bridge. Okay, so that the THC will be bridged by the acetoacetate towards the vanillin. Okay, then you will be able to forming this kind of back compress. So once, okay, you put under an acidic environment, okay, under the hydrochloric acid, then you will be able to see, okay, the purple color. So this kind of purple compress, okay, so we'll be able to dissolve, okay, into the chloroform layer. So that when you add into the chloroform, okay, so you will see the bottom layer, the chloroform layer, it is not colorless, they will turn into purple because the big compress, okay, will also be dissolved into the chloroform. So that you will be able to see, okay, purple over purple, okay, at last. So I repeat, okay, you have to follow the exact color changing sequence, okay, If you will be only seeing colorless purple and purple over colorless, that is a negative result. So bear in mind for that. It has to be colorless to purple over purple, okay, for the positive result of the quinoline reagent. The fourth kind of primary color test, so that is the enriched reagent. So that is to use, okay, to test the presence of the LSD. So LSD, it is a very common kind of hallucinogen that we find, okay, for some crime cases. So that is the reason why we also check for that. For the enriched reagent, it contains one solution only. So that will be the 1% DMAB. So that is the p-dimethylaminobenzylaldehyde. So in the concentrated hydrochloric acid together with the ethanol. So with the presence of the LSD, then you will be able to see the purple color. So actually that will be quite straightforward. So if you can see purple after you add in the enriched reagent, so that is the LSD. Actually, we have a similar kind of reagent, that is the Van Eyck reagent, okay, to be used, okay, in the same way. But for the Van Eyck reagent, we keep the main ingredient, so that is the 1% p-dimethylaminobenzylaldehyde. But right now, we are replacing the hydrochloric acid to be the sulfuric acid, and ethanol will be replaced by another oxidant, okay, but they are used for the same way, okay, to test for the LSD. For the color formating property, it is also based on the conjugated double bond, but inside the LSD, you won't be able to find, okay, the aromatic ring. What you can find, that is the indole group there. So actually that is a 5-member ring with a nitrogen, a double bond. So that is the indole group. So we have one indole group from the LSD, and then we have another indole group, okay, so from another LSD. Okay, so right here, we are applying the DMAB, so as a bridge, okay, to bridge the 2 double bond, so conjugated, then you will be able to see, okay, the purple color. So actually, the reagent for the enriched reagent that is quite specific to the Indo group. Okay, so that is where we have the LSD. But at the same time, if you know about a little bit on the biochemistry, so actually we have a certain kinds of amino acid. So that is the tributane. Okay, so tributane, that is a certain kinds of amino acid. It also contains the Indo group. So if right now we are checking with some natural material, okay, so some natural products, okay, so natural product, it will contain some protein, some amino acid. So if it is the case, it will also give you a false positive result, okay, in the enriched reagent. So it's not LSD, but indeed it is the tributane, okay, that is a certain kind of amino acid there. So therefore, you could be imagine that by using the enriched reagent, the result you may have a false positive if you are now checking with some natural material. The last kind of primary color test, so that is the Scott test. Scott test is to use, okay, to test for the presence of the cocaine. So for the test, they will contain 3 different reagents. So 2% cobalt, and then the second one will be the concentrated hydrochloric acid, and then the third one will be the chloroform. So actually, okay, you have to add the 3 reagents separately, one by one, into the unknown drug sample. So once you add in the 2% cobalt, actually you will be able to see the blue color. Then you add in the concentrated hydrochloric acid, then you will be able to see the pink color. So at last, okay, if you add in the chloroform, then you will be able to see the pink over blue color. Okay, so that will be somehow also like a sequence as we have been mentioned in the Quintus Lewin reagent. But this time, for the positive result, that will be the blue change to pink, and then that will be pink over blue. And as you can be seeing, the first reagent will contain cobalt. So actually, the color formatting principle will also be cobalt metal complex. Okay, the first blue color that is related to an octahedral cobalt complex. After you add in the hydrochloric acid, the side group has been changed a little bit so that it becomes pink color. So once it dissolves into the chloroform, okay, the octahedral complex will become the tetrahedral one. Actually, color will be changed, okay, as well. So actually, what you can know is, no matter what, okay, just try to add the 3 reagents somehow one by one, okay, into the sample. So if you could be seeing the correct color sequence, then obviously that could be a cocaine. So besides, okay, checking cocaine, Scott test will also be applied to the checking of the ketamine, but that will be in an alkyne condition. So what it means is we try to change the second reagent to be a sodium hydroxide. Okay, so we try to change the hydrochloric acid to become the sodium hydroxide. Okay, so that under that kind of situation, you could be able to check, okay, whether that is the ketamine or not. Okay, so right now we have been mentioned to you for the 5 different kinds of color tests. So started with the Marcus reagent for the opium derivative, amphetamines, and also the ecstasy. For the daily company reagent, then that could be the barbiturates. For the Quintus Lewin reagent, so that will be the marahunus for the THC. For the enriched reagent, that will be the LSD. And then for the Scott reagent, either cocaine or the ketamine. So right here, you may imagine, so if we only be provided with the 5 primary color tests, from try and error, we may, okay, to have to apply, okay, all the 5 primary color tests. Marcus reagent negative, Ferry Company reagent negative, the Quintus Lewin reagent negative, enriched reagent negative, Scott reagent positive. Then actually that will be quite wasting your sample, okay, because there will be somehow under a try and error approach, okay. The first step, okay, that I have been mentioned to you is for the drug analysis, One of the difficulty that is the sample size, okay, could be quite small. If we apply all kinds of color tests there, and all the color tests, they are destructive, okay, then you cannot recover back your sample. Then maybe you don't have sufficient sample to pay, okay, with the confirmatory test, and then that will be in a disaster. So that we need some guideline, okay, in order to lay out what kinds of primary color tests we should apply, somehow under a systematic manner. That is the reason why we need, okay, for the preliminary color test. For the preliminary color test, so that is the Mayer's reagent. Okay, so that is the first color test that you need. Okay, as the preliminary test in order to help us to sort out, okay, a systematic approach. Okay, so which one inside the primary color test should be applied. So basically, for the Mayer's reagent that will be used, okay, to the test for the presence of the alkenoid. So alkenoid, it is a class of the organic compound. But actually, if you check with the chemical structure, so opium derivative, amphetamines, and also cocaine, actually they are a alkenoid. Okay. So what I mean is, if now, okay, if you apply the Mayer's reagent into the unknown sample, if it is a positive result, that means, okay, it could be opium derivative, could be amphetamines or cocaine. So actually, the primary color test that you need would be the Marcus reagent or the Scott reagent. So actually, you are applying 3, okay, color tests at most. If it is a Mayer's reagent for a negative result, then you omit that is opium derivative, not amphetamines and not cocaine. Then you may try to apply the daily Copenhagen reagent for the barbiturates and which reagent for the LSD, or even the quinosamine reagent for the THC. So actually, you now have a way in order to make sure the color test approach, it is quite systematic. For the Mayer's reagent, inside we have the mercury chloride together with the potassium iodide in water. So once we have the alkenoid presence there, actually the mercury iodide will be precipitated out, so that you will be able to see the creamy white precipitate. So with the creamy white precipitate, then you know, okay, that is a positive result for alkenoid. Then you will be pursuing to say, okay, it could be opium derivative, it could be amphetamines, or it could be the cocaine. Then you will try to apply the Marcus reagent or the Scott test. So actually, that is the systematic way how we do it. Okay, so actually that is the general scheme. Okay, how we apply the preliminary test together with the primary test. Okay, so at the very early beginning, okay, so Marcus reagent, if you can see the creamy white precipitate, then that will be the opium derivative or the amphetamines or even the cocaine. So that's why you could be try Marcus reagent. So Marcus reagent purple will be the opium derivative, brown color will be the amphetamines, and then black color will be the ecstasy. So if it is still negative, then we try for the Scott reagent for the cocaine, then blue to be pink over blue. Okay, or even you change it to the alkyl medium, then it could be the ketamine. So in another route, okay, the negative result for the Mayer's reagent, then you will be seeing the daily Copenhagen reagent for barbiturates. If not, then we try to apply for the enriched reagent for the LSD. And for all the natural material, or in the right-hand side, you may try to apply the quinosamine reagent. Okay, so that will be colorless to purple over purple, okay, for a positive result with the THC. So actually, that will be the systematic way, okay, how we do it. Okay, so we don't try to apply quite a lot color tests because owing to a situation that the sample size may be quite tiny, quite small. But in case that if now, okay, you are having a lot of sample, okay, you have a lot of sample, so that using it for the color test, it is not wasteful. So, okay, then you could be apply as many as you can. That is the reason why we further have the secondary color test. So normally for the secondary color test, there will be 2 purposes there. The first purpose, that is to further confirm the result from the primary color test. Okay, so to further confirm the result of the primary color test, the second aim for the secondary color test is in order to differentiate, okay, so what it is, okay, so to tell apart. So actually on the slide right here, we have been mentioned to you 3 different secondary color tests. So right here, we have the marquee reagent. So right here, marquee reagent, if it is opium derivative. So imagine that you now have the morphine, heroin, or the codeine. Actually, it will turn the Marcus reagent to be purple. In order to further confirm that it's really purple, then we try to apply the marquee reagent to see whether it turns into green or not. If it is turning to green, then we double confirm that that could be the opium derivative. And other kinds of secondary color tests, we use it in a similar way. That is the KN reagent. So KN reagent, that is another kind of reagent we check for the THC. Okay. So if we now have the neutrino-serving reagent having color less to purple over purple, maybe we try to add in the KN reagent. If the KN reagent turn into red color, then we further confirm, okay, that would be the THC there. For another approach, okay, in order to differentiate out what it is, okay, it will be illustrated, okay, at the blue rectangle right here. So that is a Simon's reagent. So for the Simon's reagent, it will be help us to differentiate out whether that is the amphetamines versus the methyl amphetamines. Because from the Marcus reagent, we know, okay, the amphetamines and the methyl amphetamines will turn into brown color. So you cannot know, okay, whether that is amphetamines or methyl amphetamines, okay, because both of it, okay, will turn the Marcus reagent to brown. But with the use of the Simon's reagent, then we can differentiate out which one is which. Because for the Simon's reagent, it will only turn the methyl amphetamines into blue color. For the amphetamines, it won't, okay, have any color change. So therefore, with the blue color change, okay, for the unknown sample, then we obviously know that that will be the methyl amphetamines, that is the ice, instead of the normal amphetamines. So actually, just try to illustrate out the 2 different purposes to apply the secondary color test. But actually, for the secondary color test, we do have a lot, okay? Apart from the 3 that I have been mentioned to you, okay, the marquee reagent, the KN reagent, and also the Simon's reagent. So I will also further introduce you with some of the others, okay, also achieving the purpose that we lay out, further confirm what it is, and also to differentiate out what it is. So here I showed you the Lieberman reagent. So that is used, okay, to differentiate out the amphetamines and the methyl amphetamines. So actually that is the same purpose as the Simon's reagent. So right here with the addition of the Lieberman reagent, the amphetamines will turn into green color. And for the methyl amphetamines, that will turn into brown or a little bit red color, okay? So actually you will be saying, okay, the color of the amphetamines and the color of the methyl amphetamines, actually they are different. So that with the use of the Lieberman reagent, so that is the 10% potassium nitrate in sulfuric acid, then you could be able to differentiate out whether that is the normal amphetamines versus the methyl amphetamines, that is the ice. Also for the same thing, okay, for the Marcus reagent, both of it, okay, they will turn into brown color. But right here, with the use of the Lieberman reagent, then we will be able to know which one is which. For the other kinds of secondary color test, that is the Folders reagent. For the Folders reagent, we try to make a differentiation towards the opaque versus the alloy. So opaque, okay, so that is the opium derivative. So they are the morphine, heroin, and also the codeine. And for the alloy, so they are the synthetic painkiller. Okay, so synthetic painkiller. So for those kind of synthetic painkiller, in order to achieve, okay, the painkiller function, okay, actually their structure will be quite the same as the morphine, heroin, and the codeine. So actually, if you are not having the synthetic painkiller, while you are applying the Marcus reagent, actually you will be seeing the purple color as well. From that purple color, there is no way for you to differentiate out whether that is morphine, codeine, heroin, or even the synthetic painkiller. But right now, with the use of the Folders reagent, then you have a way to do so. Because the Folders reagent will turn the opiates, okay, the morphine, heroin, and the codeine into purple color. Okay, so purple will be the natural one. But for the synthetic painkiller, that will be blue color. Okay, so that will be blue color, okay, for the synthetic painkiller. So you can now, okay, differentiate out whether that is the natural painkiller or the synthetic painkiller. So actually, the Folders reagent, you can use it in this way. So still, okay, for the same purpose, differentiate out which one is which. For the Madeleine reagent, so that is to use, okay, to test for the methamphetamines or even the amphetamines. So actually, that will be the same thing as we have been talking about in the Lieberman reagent and the Markey reagent. Because you could be see, okay, the green color that is resulted from the amphetamines and the methamphetamines, actually they are not the same. Okay, they are green, okay, but they are different kinds of green color. But for the Madeleine reagent, it is not only to use, okay, to tell apart of the amphetamines versus the methamphetamines. Actually, that is a quite important reagent to test for the presence of the ketamine. So previously, when we are talking about the Scott reagent, so we have to modify a bit, okay, for the Scott reagent to be used in the alkyl medium, okay, so that we can test for the ketamine. But without any modification, Scott reagent will be used for the cocaine only. So right now, if you don't have any modification, then how you test for the ketamine? So that is the responsibility for the Madeleine reagent. So Madeleine reagent, 1% ammonium metavalidate, okay, in sulfuric acid, will be able to turn, okay, the ketamine to orange color. So with the orange color, okay, obviously you know, okay, so that is the ketamine. So it will be quite straightforward to do so. So no need to do some modification on the Scott reagent. If you now have the Madeleine reagent, so just add in to the unknown. If it turns into orange, so that will be quite obvious that that is the ketamine. So for the Markey reagent, we know it already. So for the Markey reagent, we use it for further confirm, okay, the heroin, morphine, and the codeine. Because three of them will turn the Marcus reagent to purple. So right now for the Markey reagent, okay, so 1% selenous acid in sulfuric acid, okay, actually will turn those kinds of opium derivative to green, okay, so we've just further confirmed, okay, that is the opium derivative by the use of the Markey reagent. Simon's reagent, we have been mentioned already, okay, in order to differentiate out whether that is the amphetamines and the methamphetamines. Because for the amphetamines and the methamphetamines, they will turn the Marcus reagent both to brown. But right now, only the methamphetamines will turn the Simon's reagent to blue. So that is how we make a differentiation. So for the Simon's reagent, we have two bottles of reagent, so we have to add it somehow separately. Okay, but still, okay, what we try to focus is to see whether we have the blue color or not. So the last kind of reagent, that is the KM reagent, as I have already mentioned. So that will be used, okay, to test for the THC as well. So somehow it is also being used for double confirm, okay, the result of the Quinones-Levine reagent. So after you add in, okay, the reagent, okay, actually it is a certain kinds of fast ruby salt, okay, in the cold form together with the sodium hydroxide, then you will be able to see the red color. Okay, so when you see the red color, then that is a positive result for the KN reagent. Okay, so for the test of the Mara Luna double confirm the result of the Duquesne-Lawson-Lewin reagent. So we still have the further kinds of color tests for the prescription drug. Okay, so just let you know for information only. Okay, so not only we are checking for the elicited drug. Okay, because when we are talking about at the very early beginning. Okay, so when we are talking about the drug. Okay, so positive effect, but if you abuse that, then there will be negative. But we have the legal one versus the illegal one. So therefore, not only the illegal one, we have to provide it with the color test for screening, but actually for the legal one, if it is quite suspicious, then we still can check for that. So we have the reagent to check for the legal drug. So the first one that is to check with the quite common kinds of drug that has been treated for the blood pressure. And then for the second one, that is the quite common kinds of drug for the anxiety. Okay, so actually, these kind of drugs are commercially available, but only that they will give you some good feeling. Okay, after you're taking the drug, people may try to addict it. So that we have this kind of color test for the purpose. So to apply the color test, as I have already mentioned to you, we have to make use of the spot plates. Okay, so somehow we try to separate the spot plate into two rows. So one row for the blank and then the other row for the sample, so that we try to see whether we have any false positive result if we just add in the blank. Okay, if it is positive, then the positive result in the sample may be quite doubtful. So actually just having the blank, in order to make a comparison of the color change. Okay, so right at this moment, so any questions or problem regarding to the color test that we use, in the screening, of the drug analysis. Before I keep going, to talk about another kind of screening test. Okay, so there is one question. So how much the reagents should be used? So actually, several drops, will be good enough. Because just depending on how much sample you have. So just several drops of the reagent towards the drug sample. So most of the time that will be powder. So actually, it will be quite easy for you to see the color change already. As you are now applying the drug sample on a spot plate, actually several drops will be good enough. Okay, so I guess right now we don't have any further question. Then we move to the next kind of screening test. So the next kind of screening test that we could use, that will be the microscopic analysis. For the microscopic analysis, actually we have two different kinds of microscopic analysis. So under the microscope, we can check with the morphology of the plants, and then under the microscope, we can check with the microcrystal that we grow with the unknown drug sample. Actually, I would say, we are a chemist. So actually, we are not quite bothered with the morphology test. So I will only have one slide, later on to show you how the morphology test is used. What we try to focus, that is the microcrystalline test. So microcrystalline test. So under the microscopic analysis would be another kind of screening test that we will use commonly. So most likely we will try to add in still some reagent, and then crystal has been formed. Then we try to compare the size and the shape in order to know what it is. But we try to get to know the details. So one slide later, because the slide that is the only one that I will show you with the morphology test. For the morphology test, mainly that will be related to the plant's material. So obviously, the most common kinds of plant material that is illegal, that is the marijuana, so that is the cannabis, or in Chinese, that is the daimafa. So for those kinds of plants, we try to check it under the optical microscope to look for those kind of botanic feature. So most probably we will check with the leaf, because on the leaf, if you can find both the needle like the sharp needle, or you can find the mushroom-like needle, actually they are the two unique feature for the Mara Luna. So actually you can just check with the leaf and then you will be able to know whether that is a Mara Luna or not. So actually it is quite specific to do so. But what I want you to pay attention, that is the microcrystalline test. For the microcrystalline test, we have the drug sample, okay? So now we try to add in some reagent. So the reagent now that is a little bit quite general. It could be gold bromide, gold chloride, or even the other. So I will show you more chemical in the next slide. After we are mixing the reagent together with the unknown drug sample, actually some crystal of the drug will be formed. Okay, so from the drug sample, okay, from the crystal that is being formed, then we try to check with the reference book. Okay, so looking under the microscope, try to look for the size and the shape, then we will know what kinds of drug are there. For example, on the slide, okay, on the top right hand corner, that is the crystal, okay, built by the amphetamines. And then for the picture, okay, at the bottom right-hand corner, that is the crystal built by the methyl amphetamines. Okay, so actually methyl amphetamines versus methyl amphetamines, actually they are not the same, okay, from the crystal that is being produced. So actually from some experienced investigator or experienced analyst, so actually they will be having the reference photo together with the unknown photo, then they will try to match, okay, to see whether what kinds of drug, okay, are there. So what I mean is for the microcrystalline test, always we will be resulted with a positive result if it is a drug. The only question is, can we, okay, identify what kinds of drug it is? Okay, because those kind of crystals are quite specific. Those kind of crystals are quite unique, okay? So always we are having with the positive result. But owing to the nature, most of the time, people will try to make use of the color test as the screening test, and microcrystalline test will not be that preferred. Actually, there are two reasons. So the first reason that is related to the reagent that we use. Although you can be seeing that the reagent that we use that is quite general. You can see gold bromide, gold chloride, lead iodide, mercury chloride, platinum chloride, or even zinc chloride. Actually, there are some quite general chemical, not that specific. But if you check with the ingredient, so gold bromide, gold chloride, platinum iodide, platinum chloride, actually, they are quite expensive, okay? So when we compare to the reagent that we use to the color test. The other thing that you may be beware of is the reagent that we use in the microcrystalline test, some of that, okay, they are quite toxic or harmful. You can see lead, you can see mercury, you can see bismuth, you can see cadmium, you can see chromate. Actually, they are certain kinds of harmful substance. Actually, nobody would like to making use of some expensive reagent or making use of some relatively harmful substance to conduct a test. So that is the first reason why, okay, color test that will be preferred over to be used for the screening instead of the microcrystalline test. The other reason that is related to the sample preparation. So you will be imagine that if you are using the color test, so you just put the sample onto the spot plate and then you just add a few drops of reagent, then color will be observed. So that will be quite straightforward, no sample preparation. But right now for the microcrystalline test, you have to get with the microscopic slide, okay? And then you need, okay, to have the cover strip. Together, you need to add in the reagent, you cover it, and then you put it under the optical microscope for the observation. Actually, the sample preparation, so you need to do so. After that, you need to observe it under the optical microscope. Actually, that will be under microscope, okay, instead of your naked eyes, okay? If you are checking with the color test, that will be your naked eyes. But right now, microcrystalline test, you need to use, okay, a microscope. Okay, actually you need an extra equipment to do so. For the microscope, it could be bright field or dark field, and most likely we try to making use of the dark field, okay, to achieve our purpose. Because for the dark field, we will be having a better resolution, okay, because for the crystal that we have, okay, most likely that will be colorless in nature, okay. So therefore, we will have the dark background together with the bright crystal, so that it will be having a better contrast and resolution for you to observe, okay, the size and the shape in order to identify what kinds of drug are there. Okay, so I believe I have furnished the things, okay, on the screening test. So any questions or problem at this moment? So I hope I finish one more slide, okay, on the sample pre-treatment before letting you go. So what just one slide more, okay, so one slide only. So now, okay, you may assume, okay, after you conduct the screening test, okay, tentatively you know what it is. Then you have to make your solid sample, because mainly they are the powder or tablets into a sample solution. So actually, in order to make it as a sample solution, simply you now have a container, okay, let's say a beaker. Then inside you have the drug sample, and the drug sample contains the active ingredient that you want to measure. So most likely you try to add in, okay, some appropriate solvent, okay, in order to dissolve, okay, the whole drug sample. So that will be a way that we are doing a dissolution. So owing to the situation that the matrix may not be that severe, then you will have the easy way out, okay, so that you try to dissolve, okay, the whole drug sample, okay, then you will be able to having the drug sample solution. So active ingredient are there, and then the whole drug are being dissolved, okay. So actually that is quite in a simple way, then you try to make a complete solution. But sometimes you may worry about with the matrix effect, then you may go for an other approach. So that would be an extraction approach. But for the extraction approach, okay, we still try to make it easy. So what it means is now the solvent that you use will only be used to extract out the active ingredient. So what it means is after you pay with the extraction, so only the analytes will be dissolved out, and then the drug sample will still be there. So after you could be having the solid and liquid separation, then you will have the analyte, the sample solution ready. So actually you have the two way, you completely dissolve the whole drug sample. If you worry about the matrix effect, then you try to make with an extraction. So sometimes you can be using ultrasonic bath, okay, to assist you for the dissolution or to help with an extraction. So that is what I want to share with you for today, okay. So next Tuesday, so I will finish those kinds of stuff, okay, in the confirmatory test and also in the retest, okay. And I guess I can start the new lecture material on the forensic toxicology on next Tuesday, okay. So thanks for attending today's class, and I'm quite sorry that I have to work at home, okay, today, okay, so that you can see it is not a real report, okay, so you can be see my writing somehow that is got press already, okay. So see you next time, and if you have any question or problem, just stay behind and ask. So one student asked about the Simon's reagent. So actually there will be 2 bottles of reagent for the Simon's reagent. So actually if you are now seeing with the reaction mechanism, okay, so you will be seeing we have the methamphetamines or even ecstasy. So actually it has been modified and then reacted with the dye. Okay, so actually you have the dye there, okay, in order to be forming a complex of the blue color. So actually the later reagent will be just added in as a solvent in order to somehow complete the reaction, somehow resulted with the complex that we want, okay, for the blue color.